In today's lesson, we're taking a look at parallel and perpendicular lines. To begin with, let's look at parallel lines. They are lines that contain the same slope but different y-intercepts. And sometimes you're going to see parallel lines with the symbols that looks just like that. Well, not just like that. There should be a little bit closer together in parallel. Sorry about that. But that's your parallel lines. So if we take a look at our first example, write an equation of the line passing through -3, 3, and is parallel to the line y equals -2x plus 1. Well, first off, we're writing an equation. Okay? When writing an equation, you have to at least know two things. You have to know the slope, and you have to know the point that it's passing through. Well, we do know that we're passing through the point of -3, 3. To get the slope, we're going to take a look at the line that they give us, because we just learned that to be parallel, we have to have the same slope of the line given. Since this equation is in slope-intercept form, I can easily pull out that my slope is -2. So now I know a slope and I know a point, so I can use either point-slope form or slope-intercept form to get me my equation. Most of us have chosen to use point-slope form most of the time, so I'm going to use that to begin with. So in here, I know my slope, I know my point, I apply my formula. Y, and the opposite of the y value given, equals my slope of -2 times the quantity x and the opposite of the x value given. There's point-slope form. Now, if you were taking a multiple choice question, I would stop there and take a look at the answers given. If the answers are in point-slope form, we stop. If it's slope-intercept form or standard form, we continue on. Look at the directions, see what form it wants you in. If it doesn't state it, then go ahead and look at your answer choices if given. If nothing is given, my suggestion is to go ahead and put it into slope-intercept form, so it's easy to compare. So we're going to continue on and put it in slope-intercept form, which means I have to distribute that -2 first. So y minus 3 equals -2x minus 6. To get it in slope-intercept form, I need the y by itself, so I'm going to add 3 to both sides, so I get y equals -2x minus 3. Now I have an equation in slope-intercept form of a line that's parallel to the given line that runs through the point -3, 3. Now let's take a look at perpendicular lines. Perpendicular lines are lines that contain the negative reciprocal slope of each other. And the symbol for perpendicular is the upside down capital T. Now, negative reciprocals. Negative actually means the opposite value of, and we know the reciprocal is the fancy word for flip the fraction. So, in our examples here, what would be the negative reciprocal of the following? They're giving us the fraction 2/3. The negative of it, or the opposite of positive 2/3, is going to be a negative. And then the reciprocal, we're going to flip our fraction upside down to be 3/2. That's the negative reciprocal of 2/3. So when we look at example B, -1/3, since it's already negative, the opposite's going to be a positive. We're going to flip our fraction upside down, which would be 3/1, but we always simplify, so that's just going to be 3. And in C, we're given the whole number, -5, so the opposite value of -5 is a positive. That's really 5/1, so when I flip it, I get 1/5. The negative reciprocal of -5 is 1/5. Now let's put it to use. We want to determine whether the lines are perpendicular or not. To be able to do that, I have to know the slope of each line. So let's take a look at line A first. 3y equals 2x minus 1. To be able to find the slope, the easiest way is to go ahead and get it in slope-intercept form. So I'm going to divide both sides by 3. On the left side, I'm left with y. On the right side, I'm going to do my double division, so that leaves me with 2/3 x, and then negative 1 divided by 3 is a negative 1/3. Now I'm in slope-intercept form, so I can see that my slope is 2/3. In line B, again, I need to simplify, so I need to get that y by itself, so I'm going to divide both sides by 2. Left with y equals, the first division is negative 3/2x. The second division is a positive 21/2. So now that I'm in slope-intercept form, I can show that my slope is a negative 3/2. Now compare your slopes. I've got 2/3 and negative 3/2. Are they negative reciprocals? Yes. Therefore, my lines are perpendicular. In our next example, write an equation of the line that passes through 4, negative 2 and is perpendicular to the line y equals 4x plus 2. Again, we're writing an equation. So to be able to write an equation, I have to know the slope and I have to know a point. I do know I want it to pass through the point 4, negative 2, and I want it perpendicular to this line right here. Well, this line right here, I have a slope of 4. But to be perpendicular, I need the negative reciprocal of that slope. So the negative reciprocal would be a negative 1/4. That's the slope I'm going to use along with my point. So I'm going to use point-slope form. So I'm going to substitute into my equation y, and the opposite value of y is a positive 2, equals my slope of negative 1/4 times the quantity x, and the opposite value of a positive 4 is a negative 4. And again, then I want to go ahead and look at my answer choices or look in the directions. What form does it want me in? Again, it doesn't specify, so my suggestion is to go ahead and put it in slope-intercept form. So I'm going to distribute that negative 1/4. So I get y plus 2 equals negative 1/4 x plus 1. To get into slope-intercept form, I need the y by itself, so I'm going to subtract 2 from both sides. So I'm left with y equals negative 1/4 x minus 1. So this line is perpendicular to the line given that runs through the point 4, negative 2. In our last example, we're going to pull it all together. We're going to determine which lines, if any, are parallel or perpendicular. Now, to be able to compare, we have to know their slopes. So let's take a look at line A to begin with. In line A, I'm kind of in standard form. However, our A value is negative, so it's not proper standard form. But from that format, I cannot find my slope. So I'm going to go ahead and put it in slope-intercept form. To do that, we need the y by itself. So I'm going to add x to both sides to start with. So that leaves me with 3y equals x plus 1. To get y by itself, I need to divide by 3. So y equals 1/3 x plus 1/3. So now I can easily identify my slope as 1/3. Let's take a look at line B. In line B, well, looky there, we're already in slope-intercept form, so it's very easy to identify our slope of negative 3. So let's move on to line C. In line C, we're in standard form, so I need to move the 2x over to the right-hand side, so I'm left with negative 6y equals negative 2x plus 4. To divide by negative 6, y equals negative 2 divided by a negative 6 is a positive 1/3 x. Positive 4 divided by a negative 6 is a negative 2/3. So here I can identify my slope as 1/3. All right, so now that we know all the slopes, let's look for parallel lines. To be parallel, they have to be the same slope. When I take a look at my slopes, I've got a slope of 1/3, -3, and here's a 1/3 right here. So your parallel lines are lines A and C. Perpendicular lines, once again, remember those are lines that have negative reciprocals. Well, lines A and C are parallel, however, they are perpendicular to line B. So lines A and C are perpendicular to B.